this syllabus, or we call as PPPU. So I will share the link. Okay, any question? Oh, here we also have the title or topic for your task. Actually, task will cover for chapter 3. Where is it? Tak apalah, nanti kamu just go through. If you have any question, just ask. Okay? Okay, shall we start with our content? Okay, for chapter 1, we have 3 subtopic, 1.1, 1.2, and 1.3. So 1.1 and 1.2 actually the revision from your previous syllabus in your school. So describe, define proton, nucleon, isotope, write the isotope notation. Okay, here we have calculation for average atomic mass and relative atomic mass. Okay, then for 1.2, we have Avogadro constant, interconvert between mole, molecules, ion, and molar volume at 2 different conditions, STP and RTP. Then we will define empirical and molecular formula and calculate, give the empirical and molecular formula from different type of question. And last, define and calculate for the 5 concentration measurement, molarity, molality, mole fraction, percentage by mass, and percentage by volume. Okay, actually, in these 2 hours, I think we can cover 1.1 and 1.2 subtopic. Okay, and I will cover for 1.3 next week in class. If you have any question, just interrupt me. Okay, for 1.1, okay, learning outcome. Okay, what you should know after this lecture. Okay, you should be able to write isotope notation, interpret mass spectrum, and calculate average atomic mass and also relative atomic mass. Okay, this one is isotope notation. Okay, actually yang ni pun kamu dah belajar dulu ni. So X will represent anyone? X represent?
X represent
symbol
element.
Of the X.
Element.
Element symbol.
Okay. A represent?
A represent nucleon number.
Yes. And Z is?
Proton number of X.
Proton number. So nucleon number is proton plus neutron.
Yes.
Okay, ini just revision from your previous okay, so for example, we have mercury, Hg, so nucleon number 202, so proton number 80, to get the neutron number just minus 202 minus 80, so we have 122. Okay, so can someone answer this question? I don't have your list name.
to mercury,
Okay. Okay. Mercury, proton,
proton
80.
80,
80, neutron,
120,
120.
okay, 120, and electron,
80.
80. Okay, so here we don't have charge for mercury. So sini just Hg saja tanpa charge. So means electron and proton we have the same number. Okay, so charge equal to
0.
0. Yes. Okay, the next one, copper,
Proton 29.
29. Yes.
Neutron 34.
63 minus 29, 34. Yes. Electron,
34. Electron 0.
Can you touch?
0.
huh?
Is it 0?
Okay, ini tadi 80. So neutron 120, electron equal with proton 80. So no charge.
Oh,
Copper. Copper tadi berapa? Sini proton
Proton
29, neutron
24.
63 minus 29, 34, electron
29.
29 also, charge
0.
yes 0. Okay, now we have oxygen 2 minus. So proton
8.
8, neutron
9.
9.
okay 9, 17 minus 8, 9, electron
10.
8.
10. Yes, we have a negative 2
Oh.
charge, so we have more electron than proton. So 8 plus 2 will become 10. So charge,
Negative 2.
okay. This one CO3 plus, proton,
27.
okay, 27, neutron,
32.
32, 59 minus 27, okay, and electron,
24.
yes, 24. So 27 minus 3, okay, then charge, positive. Okay, so this one is notation. So notation we write as element A and A and Z. So here. So we have element A. Okay, here is
4.
4. Okay, proton plus neutron 4. Proton
2.
equal to 2.
2.
So
2.
4, 2. B
3.
3.
1.
1.
1.
Yes.
Do we have charge?
Yes.
Yes.
Okay. What is the
Positive 1.
charge? Positive 1.
Yes.
Okay, why positive 1?
It's because electron has less number than proton.
Okay, because electron is 0, so proton 1 less than proton. Okay, next C
2.
2,
2.
proton
1.
1. Do we have charge?
No.
No.
No. Okay, next D
14.
14,
14.
7
7,
minus 3 and negative 3.
negative,
7.
negative or positive?
Negative.
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 Negative 3.
Okay.
Negative.
Okay, so that one for isotope. Okay, so this one is about mass spectrum. Okay, mass spectrum is actually this one.
Vaporization chamber.
Okay, the data that we get from mass spectrometer. So the device itself we call as mass spectrometer. So we have 5 main part in mass spectrometer. Okay, starting with vaporization chamber, ionization chamber, acceleration chamber, magnetic chamber and ending with ion detector. So this ion detector will detect the result and printed it as mass spectrum. Okay, so this five main part we can write the short form as VMIN. Actually, this one is not in your syllabus already. In your syllabus, we just calculate, we just concentrate about the mass spectrum only. But we should know the mass spectrum is come from mass spectrometer. Okay, this is the mass spectrum. Yes? Any question?
No.
Okay, mass spectrum of magnesium. Okay, so here we have three peak for magnesium. Actually, why we have three peak for magnesium?
Isotope.
Three
Yes,
isotope.
because we have three isotopes for magnesium. We have magnesium 24, magnesium 25, and magnesium 26. So each isotope will give you the different relative abundance or percentage. So the most abundance or the highest percentage is referred to isotope magnesium 24. So magnesium 24 ni yang kamu nampak di periodic table. Okay, magnesium dia sebagai 24, bukan 25 dengan 26. 25 and 26 exist but in low percentage. So this one is mass, M over E actually is mass over electron ratio. The relative abundance can be in ratio or also can be in percentage. So we have three isotopes of magnesium. Okay, the highest peak represent the most abundant isotope. So refer to magnesium 24. Okay, now calculate the average atomic mass from this mass spectrum given. So we have this formula, average atomic mass equal to summation of key times me over summation of key. Actually, key refer to quantity. Okay, quantity can be represented by ratio of percentage. Me actually is mass. M is mass. Okay, relative abundance, or we call as quantity, can be in percentage or ratio. And me is the isotope of the element. So we have unit for average atomic mass. So the unit depends on the question whether U or AMU. Or if the question do not give any unit, we just write as U. But average atomic mass, we need to write the unit. Okay. Here we have relative atomic mass. What is the difference between average atomic mass? Okay, this one is average. Average. This one is relative. Apa perbezaannya selain daripada spelling?
Satu
Unit.
tiada unit.
Yang mana yang tiada unit?
Relative atomic mass.
Okay, why relative atomic mass with no unit?
Cancel.
Cancel? Why cancel?
Divide by
Divide by?
1 over 2 carbon.
one per 12 times 12 carbon.
Yes. Relative actually refer to comparison. We relate. So we compare mass of the atom with mass of carbon 12. So that's why, as your friend said, we need to cancel out the unit by comparing with 1 over 12 mass of carbon 12. Actually, the formula same as average atomic mass, summation of K me over K. Actually, we always call this one is K me K. Okay, but here we have no unit. So in calculation of relative atomic mass, we starting with this formula. Okay, actually this formula we write as average atomic mass. Then we have another step. We calculate relative atomic mass to cancel out the unit. Okay, for example, here we have the final answer is 24.12 U. So we use the value. Okay, we relate with carbon 12, 112 mass of carbon 12 U. So we cancel U and U, 12 and 1 over 12. So we have 24.12. So this is the final answer for relative atomic mass. So remember, for relative atomic mass, we need to write the second step, average atomic mass, and the second step is cancellation of unit by comparing with mass of 112, mass of carbon 12. So far, okay?
Okay, madam.
Okay, madam. Okay.
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 Okay. So before we go for
Okay.
1.2, okay, we need to do some exercise for 1.1. That one is lecture, so this one is your tutorial note. Okay, example, we have two isotopes for copper, copper 63 and copper 65. So percentage for copper 63, 69%, and 65, copper 65, 31%. Okay, given the actual mass here, okay, define isotope. Isotope refer to, okay, two or more atoms. Okay, mesti more than one. So more than one means two or more atoms for the same element. Okay, elemen yang sama. Elemen tu means copper. Cuma yang berbezanya dia ialah copper 63 or copper 65. So two and more, two or more atom for the same element. Element refer to same element, copper element that have the same number of proton. Okay, same number of proton and different number of neutron. Okay, so we have 4 keywords for definition isotope. So if you miss one of any keyword, you don't get any mark for the definition. So remember these 4 keyword in defining the isotope. Okay, next, calculate the average atomic mass. So before we calculate, make sure you write the formula. So the formula will give you 1 mark. So the formula is summation of K me over K. Then substitute the value. So K refer to quantity. So quantity means percentage. So we have 2 isotope means we will have the 2 set of K me. So the first set is 69 and 63 isotope. So 63 isotope for copper, they give you the exact mass 62.9. So 69% times 62.9 AMU. Okay, same goes for here for copper 6. Sorry, this one is, oh yes, 31% times copper 65. So mass 64.9. Okay, and this one is summation of the percentage. Okay, final answer, we have 63.52 AMU. Okay, why here we need to round off to 63.5? Why the final answer is here?
It's because the refer to question,
Mm-hmm.
dia only have apa titik perpuluhan, satu titik perpuluhan saja. So we need follow the refer to back, macam tengok balik tu question punya titik
Yeah.
perpuluhan.
Yes, correct. Okay, here we can write it as 4 decimal point, 3 decimal point, tak kisah berapa-berapa decimal point. But in this calculation, in this subtopic, you need to refer to the question. So the question give you the mass in 1 decimal point, 62.9 ni. 0.9 ni 1 decimal point, so means final answer kamu pun mesti 1 decimal point. Okay. So this one is question from the mass spectrum given. Okay, what isotope are present in rubidium?
Lima rubidium and 87 rubidium.
Okay. Rubidium 85 and rubidium 87. Thank you. Okay, what is the percentage abundance?
18 and 7.
This one percentage ke bukan ni?
No, that's
Bukan.
This one is relative. So how do we convert this relative abundance to percentage?
relative over total relative times 100.
Yes, okay. So for rubidium 85,
18.
18 percentage-nya 18 over 18 plus 7. 25 times 100.
25.
25. So 25%.
25.
Hmm?
72.
Okay, so we have 72. So 72% for
72.
72% for rubidium 85 and 28 for rubidium 87. Okay, so remember we need to refer to this one. So sometimes they will give relative, sometimes they will give percentage. And calculate, okay, the next question, calculate relative atomic mass of rubidium. So we use the formula. Average atomic mass. So average atomic mass of rubidium, okay, formula, summation of Ki over Ki. So this one, they still use the ratio, or you can also use the percentage that you have calculated in part B. Okay, we get 85.56 AMU. Okay, now we want to calculate for relative. So we know that relative atomic mass with no unit. So cancellation of unit by comparing with mass of 112 carbon 12. So this one is relative atomic mass. So 85.56. How many decimal point? Berapa decimal point?
Two.
Bukan no decimal point ke tadi? No decimal point kan? Ini dia bagi kita 85 dengan 87. So means sini jadi berapa? This one will become 80?
85.
Yeah,
86.
86. Okay, 86.
Madam,
Yeah.
why ada 1/12 situ?
Yang ini, this one calculation untuk relative kan? So relative means kita compare dengan 1/12 mass carbon 12. Carbon 12 massnya ialah 12 gram. So 1/12 ni ialah comparisonnya.
Okay.
Okay.
Okay, madam.
Okay. Oh, ini sama tadi. So, calculation relative atomic mass from mass spectrum. Okay, we have another example. So, this one is given in ratio. So, we have two isotope for chlorine, chlorine 35, chlorine 37. So, ratio 3.127. Based on the carbon 12 scale relative blah blah blah, calculate the relative atomic mass. So how many steps?
2.
Yes, 2 steps. So first step we calculate for
Average.
yes, average atomic mass. So the formula is Km over K. So given quantity for what is the mass? Okay, mass chlorine 35. So chlorine 35, 34.9689. Okay, what is the quantity for this isotope? Or the ratio?
3.127.
Yes, 3.127. Plus, we have another one for chlorine 37, 36.9659. Okay, the ratio is?
1.
1.
Okay, why 1?
3.127 over 1.
Yes, ini fraction kan? So, over 1. So, total of quantity will become? Berapa total Q? K?
4.127.
27. Okay, yes. So second, then we calculate for second step. Okay, here we get the answer. So the answer is in U. Then after we get the answer, second step, cancellation of unit. Okay, next, example 4. So example 4, we have two. Yang tadi tu, okay sudah kan?
Okay, madam.
Okay, so example 4, we have two isotope of lithium, lithium 6 and lithium 7. Okay, given the atomic mass. Okay, now they ask to calculate for percentage for each. Mean how many percent of lithium 6, how many percent for lithium 7. So we have two unknown here. So if we have two unknown, we need to assume one of these with X. But we know that total percentage for this lithium 6 and lithium 7 will become 100%. Okay, we start with assumption. So we assume that relative percentage abundance for lithium 6 is X. And lithium 7 is 100 minus X. Because we know that these two will become 100. Can we assume this one as Y? Boleh assume Y tak?
No.
Actually, kalau kamu assume dia as Y, we need another equation. X plus 2 equal to 100. Pun boleh juga ni. Okay, yang paling simple kamu assume macam ni lah. This one is X, this one 100 minus X. Ini matematik ya, mana-mana pun mungkin. Okay, then we start with formula. Substitution. So this one is for lithium 6 tadi. So lithium 6 is X. So quantity is X. Mass is 6.01. So for lithium 7, 100 minus X. Okay, quantity is 7. Mass is 7.02. Okay, and sum of quantity is 100. Okay, this one X plus 100 minus X become 100. Okay, 6.92 given in question. Calculate for X, we have 7.92%. So after calculate, we need to do conclusion. So we conclude that percentage for lithium 6. So X represent for lithium 6. So percent for lithium 6, 7.92. And for lithium 7, 100 minus 7.92, which is 92.08%. Okay, any question for this example? Actually, this is the hardest example in calculation for mass
Means-
spectrum. Yeah. Yeah.
Why is there 702?
Oh, this one.
Yeah.
Oh, yang ni just ni je. Apa ni? Kamu multiply macam ni je.
Oh.
Yang ni
Sorry,
yang ni saya tak tunjuk pun tak apa ni. Yang ni tak tunjuk step pun tak apa ni. Yang penting kamu dapat final answer ni sama ni. Okay, yang step ni pentingnya yang this one. Before calculate, kita assume dulu. Kalau kamu mau assume dia this one y, nanti kamu perlukan this equation lah. X plus y equal to 100. Yeah.
Miss, di bagian mana ada dapat mark?
This one, assumption. Kemudian formula. Okay, this one assumption 1 mark. Assumption formula 1 mark. This one substitution 1 mark. Okay, ini semua tiada mark sudah ni. Okay, then calculation dapat X 1 mark. Apa ni? Conclusion untuk lithium 6 and conclusion untuk lithium 7. Ini macam susah sikit dan markahnya pun banyak sikit lah. Susah ke? Okay je kan?
Okay, Miss.
Hmm.
Okay, ya.
Okay, proceed. Okay,
Proceed.
so exercise. Okay, this one perlu discuss ataupun kamu cuba. Calculate the relative atomic mass. Ini given in ratio. Ini okay kan?
Okay.
Okay.
Okay, madam.
Ini simple. So this one. Given mass spectrometer. So this one ialah untuk siapa? X. So X isotope. Isotope X ada 3. Isotope 50, 52, 56. Given relative abundance. State the number of proton and neutron in, ini ada ya, isotope 52, 27. Calculate the relative atomic mass. This one simple kan?
Yeah.
Okay. This one?
Also simple.
Okay, we have 2 isotope for carbon, carbon 12 and carbon 13, and 2 isotope for oxygen, oxygen 16 and 18. So they ask for peaks in mass spectrum. How many peaks in mass spectrum? If we need to combine to form carbon dioxide. Carbon dioxide, it means 1 carbon, 2 oxygen kan?
Yes.
Okay, jadi ada berapa peaks ni? Memanglah jawab. Yalah, 6 ni jawapan dia sudah bagi sudah ni. How we get this 6 peak?
C12.
C12.
Ya.
Oksigen 16.
Okay, actually this one ialah apa? Probability, berapa kemungkinan combination 1 carbon and 2 oxygen kan?
Yeah.
Okay, so first combination 1 carbon 12. Okay.
Oksigen 16.
Oxygen
Oksigen
16.
16 also.
Okay, second one.
Carbon
Carbon
12. Oksigen 16.
Oxygen 16.
Oksigen 18.
Okay.
Carbon 12. Oksigen 18.
Oxygen
Also oksigen 18.
Okay. So ini untuk carbon 12. Then kamu buat yang the same thing untuk carbon
13.
13. Carbon 13. 16. 16. carbon 13, oxygen 16, oxygen 18, carbon 13, oxygen 18, oxygen 18. Then we get the 6 peak. Okay, untuk solution, you just write this one lah, the 6 combination.
Okay, madam.
Okay. So exercise 4, sketch the mass spectrum. This one also simple. So 3 line. So we have 3 isotope, 20, 21, 22, and each given the relative abundance. Ini okay kan?
Okay.
Okay, madam.
Okay, so we have finished for subtopic 1.1. Okay, continue for 1.2. Ataupun kamu nak take a break? Kalau just continue.
Take 5, madam.
Take 5. So kita apa? Log out ke apa?
Proceed je lah, madam. Proceed je lah.
Proceed pula.
Cannot catch up.
Huh? Cannot catch up?
Yes.
Yes.
Which part? Huh?
The calculations.
Yes, which part?
calculation part. Calculation part.
Calculation part.
Calculation part. The question of which one? You should interrupt bila kita discuss tadi. Hilang sudah saya punya which part?
Next.
Kamu kalau mau tanya, kamu just tanya saja ya, sebab nanti yang ini dia tak boleh tak repeat sudah ni. Which part?
Relative
Relative
abundance.
Relative abundance. This one?
Yeah.
Okay. Apa maksud kamu? Relative abundance,
I'm not quite clear on how to find the answer. But later can madam send the lecture notes.
In the lecture notes, lecture notes. Lecture note or the question? Lecture notes. Lecture note actually tiada soalan. Lecture note is notes. Dia just note saja. Maybe here. Ni. Relative abundance means okay.
Yang iridium kat tu.
Iridium. Oh, the question.
Did we do that?
Mana iridium? Iridium example. Oh, this one.
Yeah.
Okay. Nanti lain kali kamu just interrupt ya.
Okay, madam.
Okay. So this one.
Okay.
So we have 5 and 8. Okay, calculate relative atomic mass. So we know that to calculate relative atomic mass, we need to calculate in 2 steps. So first step we calculate for average atomic mass. So kita ada 2 step. So first step is calculate for relative average atomic mass. So the formula is apa formulanya?
Kimiki.
Yes, Kimi over K. Okay, Q refer to quantity. Quantity is whether in ratio or in percentage. But here we are given in ratio. So 5 for iridium 191. So 5 quantity times M. M is mass for iridium 191. We are given 191.5 0 to 1. Plus, we have another isotope for iridium 193. Okay, the ratio given is 8 times 193.025 divided by total of the quantity. So total of the quantity is total of this ratio, which is
13.
13. Okay, now calculate lah berapa ni? Ada calculator ke?
Ada.
Five times
196.
192.25.
192.25
5.
3 decimal point 25. Oh, this one 254. Okay, so here the unit are not given in the question, but we know that relative atomic mass dia punya step ada 2 step, so kita just tulis the unit is U, because we need to write the second step to cancel out the unit. So relative atomic mass equal to 192 over 254U divided by 112 times 12U. So cancellation of unit. So we get, actually we get the same number, but now without unit. Okay. Okay, sudah?
Okay, madam.
Okay. So ada lagi question that we need to discuss before we proceed to 1.2?
Okay, I can proceed already.
Okay. Okay, this one is lecture note for 1.2. Do you have this notes? Kamu ada notes apa-apa dah?
Tidak, madam, itu
Ada,
lama
madam.
takut.
Nanti minta ya, madam.
Nanti saya bagi link ya.
Okay.
Okay, madam.
Madam,
Yeah.
exercise number 4.
Exercise number 4.
Yes.
Exercise number 4. Number 4. This one?
Yes. Okay.
Mass spectrum ni actually graph kan? So,
Graph.
Mass spectrum ni graph macam ni. Okay, this one apa tadi? M over?
Electron.
Yeah, mass over E ratio. So, how many isotope kita ada sini?
3.
Yeah, 20, 21, 22.
3.
20. So here is relative abundance. Abundance. So 20 relative abundance ialah 91. So 91 tinggi sikit. Bukan tinggi sikit, tinggi banyak. Saya letak sini 91. 21 0 point. So 0 point sikit dah. 0.26. So 22 8.8. So ini je lah answer for question 4.
Okay, madam. Thank you.
Okay. Sekejap ya, saya cari charger saya sekejap. Okay, so learning outcome for 1.2. Define empirical molecular formula. Ini pun dulu dah belajar ni. Okay, what is the keyword for empirical formula in definition?
Real apa?
Keyword.
Ratio.
Yes.
Ratio. Real
Simplest.
ratio. Or simplest ratio.
Yeah. Simplest ratio. Boleh lah simplest real. Simplest lah selalu kita guna. Kalau molecular,
Real.
actual.
Oh, actual.
Actual.
Okay. Then define molarity, molality, mole fraction, percentage by mass, percentage by volume. Actually yang ni semua ni sudah belajar kan?
Sudah.
Sudah
Semua.
masa SPM.
SPM. Masih ingat?
Ya. Tidak. Susah, madam.
Tidaklah susah. Okay, tak apa. Kita go through one by one.
Okay.
Okay, empirical. Okay, yang ni mesti ingat simplest, tapi mesti refer to what? Simplest ratio. Okay, actually bila kita bagi tahu mesti ada perkataan simplest, kamu just tulis simplest. Tapi simplest apa? Simplest ratio for element. So, simplest ratio for all element in that molecule. So, molecular formula pun sama, actual number. Actual number for what? For each element or for all of that element. Okay, we have 5 concentration units. So, we start with molarity. So, this one molarity and molality, mole fraction, percent by mass and percent by volume. So this one relation between mass and volume and volume, mass and mass. Before we define, okay, we have 3 different terms here. We have solute, we have solvent, we have solution. Okay, kamu kena tahu exactly what is the difference between these 3 terms. So we start with solution. So solution refer to a mixture of 2 or more substances. Okay, yang dia mix. Actually, we always say that solute mixed with solvent will form solution. Solute, okay, present in a smaller amount. Okay, selalunya solute lebih sikit lah compare than solvent. So solvent is the substance present in a large amount. So in defining the 5 concentration measurement, kamu kena define dia as solute, solvent or solution. We start with molarity. Molarity capital M. So define as mole of solute per volume of solution. So the volume of solution must be in liter or decimeter cubic. Decimeter cubic dengan liter sama ya. 1 decimeter cubic equal with 1 liter. So the unit is mole per liter or mole per decimeter cubic. So we define as mole of solute over volume of solution. So volume of this solution must in liter. The next one we have molality. So molality, the symbol is small m. So this one is relation between mass and mass. So we have mole of solute over mass of solvent in kg. So the difference between molarity and molality is this one is in mass for solvent. Yang tadi tu ialah volume of solution. So mass of solvent must be in kg. So the unit is mole per kg. Okay, because we get from here. So mole of solute Okay, N is actually mole of solute over mass of solvent. So mass of this solvent must in kg. Okay, kalau kamu tengok in definition, we write specifically dia sebagai solvent, solute, sama macam tadi. So mesti tulis dia spesifik. Because nanti kamu mix, kamu akan calculate for mole solute, mole solvent, nanti which one yang mole yang you should substitute in the formula, nanti kamu confuse. So in formula kita tulis spesifik dia sebagai apa? Solute, solvent, contoh. Okay, so mass of solution, okay, we can get by adding mass of solute and mass of solvent. The next one is mole fraction. So fraction, okay, mole fraction, the symbol is capital X. So fraction tiada unit because dia pecahan tiada unit. Actually untuk this one, dia refer to mole. Actually we also can have mass fraction, volume fraction, apa-apalah yang fraction. So define as ratio number of that component divide by total number of all the component exist. For example, in that system, we have component A, component B, and component C. So we want to calculate mole fraction of component A. So according to this definition, ratio number mole for the component. So component A. Jadi dia adalah mole of component A divide by total number of all component. How many component exist?
3.
3. So total number of mole A plus mole B plus mole C. So if we want to calculate mole fraction for B, macam mana?
Number mole of B divide by number mole of A plus number mole of B plus number mole of C.
Okay, yes. Untuk calculate mole fraction of C,
Sama juga.
okay.
Number mole
Kalau
of C.
untuk calculate mole fraction of C, kalau kamu mau adventure sikit, kamu guna formula yang sama. Tapi actually kita ada shortcut. Kita boleh calculate mole fraction of C guna formula 1 minus mole fraction A plus mole fraction B. Okay, because total mole fraction will be equal with 1. Sama dengan 1. Total pecahan kan? Pecahannya total ni sama dengan 1. Mole fraction dia hasilnya 1. Jadi kamu boleh calculate untuk mole fraction C using yang ni lah. 1 minus summation of 2 mole fraction. Okay, next percentage by mass. So formula percent mass of solute over mass of solution times 100. Okay, mass in kg pun boleh, in gram pun boleh. Yang penting dua-duanya mesti sama unit. Okay, for example, kita ada 10% weight W over W. W refer to weight, weight over weight of NaOH. So we can define this 10% is actually 10 gram of NaOH, 10 gram of NaOH. Okay, so here NaOH is a solute, solvent, solution, NaOH?
Solute.
Yes, solute. So 10 gram of solute dissolved in 100 gram of solution. 10 over 100 times 100. So kita akan dapat 10% W over W. Or we can also define as 10 gram of NaOH dissolved in 90 gram of solvent. So 90 gram ni ialah solvent. So to calculate for solution, kita tahu
Plus
mass
10.
solution ialah mass solute plus mass solvent. So solute 10, ini this one. Solvent is 90. So solution means jadi 100, sama lah. Okay, percentage by volume, percent V over V. So volume of solute divide by volume of the solution multiply by 100. Sama macam tadi, cuma this one in volume. Okay, now we have this note. Volume of solution is not equal to volume of solute plus volume of solvent. Yang ini hanya kalau mass dia boleh sama. Okay, actually why volume of solution cannot be equal by adding volume solute dengan volume of solvent? Anyone? Ada sesiapa tahu?
Density.
Yes, density. Kenapa density? Yeah, actually dia ada kaitan dengan density. Density formulanya ialah mass over volume. Okay, kenapa why density? Untuk water, kita boleh assume volume, kita boleh assume mass dengan volume yang sama. Mass water, kalau dia 1 gram water, sama juga dengan volume water. Untuk water saja kita boleh samakan 1 gram sama dengan 1 ml. Okay, why? Other than water tak boleh.
Different density.
Yeah, different density. Because density of water saja yang 1 gram per ml. Yang lain maybe less than 1 or more than 1. So that's why volume solution not equal with volume solute and solvent. Oh, ini tadi sudah. Okay, so this one untuk notes, lecture notes. So we go to tutorial. Which one tutorial? This one. Okay. So learning outcome for tutorial. Okay, in lecture we just define empirical and molecular formula. Okay, here we need to determine. Determine means we calculate empirical and molecular formula. Okay, and then you will also determine the molecular formula from experiment. Okay, you have experiment 1. Okay, but experiment 1 we do after the practical assessment because we start with experiment 2. Okay, then calculate this 5 concentration measurement. Okay, so this one ialah interconvert between mole, atoms, ion and molecule. So 1 mole of any substance. So any substance means referlah sama ada dia ialah atoms, ion or molecule will be equal with Avogadro constant 6.02 exponent 23 of the elementary particle. For example, 1 mole of copper atoms. Copper atom will equal with 6.02 exponent 23 of copper atom. If we have 1 mole of substance, apa lagi contoh substance? 1 mole of copper 2 plus ion. We also equal to Avogadro constant of copper 2 plus ion. Okay, if we have 1 mole of oxygen molecule, O2 molecules equal to Avogadro constant of O2 molecules. Okay, refer lah dari sini. Substance tu ialah apa? Atoms, ion, or molecule. So nanti di sini pun dia sama. Atoms, ion, or molecule. Okay, but they will have the same Avogadro constant. Okay, 1 mole of any substance also we equal to its AR. So this one is A refer to atom or its MR refer to molecule in gram. For example, here we have 1 mole of copper, 1 mole of copper atom in gram. Copper berapa ya in periodic table? 1 mole of oxygen atom. Kalau in gram equal to 16 gram. So kalau 1 mole of oxygen molecules in gram dia ialah 32 gram. So this one equal to MR, this one equal to AR. So 1 mole of any substance equal to, okay, this one is volume, equal to 22.4 liter at STP. S refer to, STP ni apa?
Standard temperature.
Standard bukan.
Yeah, standard
Temperature, pressure.
temperature and pressure. So what is the pressure? This one, 1 atm.
1
The
atm.
pressure, temperature 273.15 K. Berapa degree Celsius ni?
0.
Yes, 0 degree Celsius. So 1 mole of any substance at STP, 1 mole of any substance equal to 22.4 liter. And we have another condition at RTP. This one is RTP. R refer to room. At room temperature and pressure. So the volume will be equal to 24 liter or decimeter cubic. Room temperature 298.15 K. So kalau degree Celsius?
25.
Ya, 25 degree Celsius. So yang ini semua conversion ni semua kamu kena ingat lah. So yang ni tak apa, yang ni boleh tengok dari periodic table. So yang this one, 22.4, 24. Ini saya rasa kamu tahu ni, ini Avogadro constant. Okay. Chemical formula, so empirical and molecular formula. So relation between molecular and empirical formula. So first we need to calculate for empirical formula. Then to get for molecular formula, we use this relation. So calculate for N. So N equal to relative molecular mass. So this relative molecular mass will be given in the question. Divide by empirical formula. So we have 3 types of question in calculating empirical and molecular formula. Okay, the question give us percentage. So we can convert the percentage to mass in gram. If the total percentage, okay, the total percentage is 100%. So kita boleh convert semua percentage tu dalam gram. Okay, or if they give us the mass for the each element. Okay, and the other one is from combustion process. Okay, combustion means apa? Pembakaran kan? Combustion we produce. Combustion means using of oxygen to produce
Carbon dioxide
and
water.
yes, and water. If we have enough oxygen or complete combustion, if we don't have enough oxygen or limited oxygen, it will produce
Carbon monoxide.
yes, carbon monoxide and water. If we have very limited, this one limited oxygen. If we have very limited oxygen,
Carbon only.
yes, only carbon and water. So water ialah wap air, steam. Okay, for example, yang the simplest example, okay, they give us percentage 40.92% carbon, 4.58 hydrogen, 54.5 oxygen. Okay, yang semua ni total is it 100%?
Yes, madam.
Okay, so kalau semua ni 100% means kita boleh jadikan dia 40.92 gram of carbon, 4.58 gram hydrogen, 54.5 gram of oxygen. So macam biasa dulu pun kamu pernah buat ni, buat table untuk carbon, hydrogen and oxygen. So carbon tadi 40.9 gram, so ini mass in gram. So hydrogen 4.58, so 54.5 gram. So semua ni. So next step after mass, we calculate for? Ingat?
Mol.
Yes, we
Mol.
calculate for mole. So mole divide by AR. So carbon ialah 12, yang ini, okay nanti tengoklah. So this one, 12. So ini divide by 1. Ini divide by 16. Okay, so sini, this one, this step, hati-hati. Okay, because we don't want you to convert, to run off to actually 1 decimal point. Actually, yang the best answer here, 3 to 4 decimal point. Okay, sini. 3 to 4 decimal point. Okay, why? Nanti bila kamu cari ratio, then we will get the deviation. Nanti akan dapat perbezaan yang untuk calculate simplest ratio. Okay, here we have 3.41. Ini 4.58, 3.41. So between these three amount of mole, yang the simplest mole is 3.41. So semua pun kita akan divide by 3.41. Okay, here we get 1, 1.33 and 1. Okay, untuk this one, 1.33, we cannot run off to 1. Okay, hanya 0.1, okay, 0.1 and 0.9 saja yang kita boleh convert, run off. Okay, for example, we have 2.1. 2.1 kita boleh run off kepada 2. Okay, kalau kita ada 2.9, okay, if we have 2.9, we can convert to 3. Okay, ada yang lain 0.2, 0.3, until 0.8, we cannot run off. Okay, this one semua kita tak boleh run off. Kita perlu cari satu yang simplest number untuk multiply supaya kita dapat the whole number. Okay, for example, this one, 1.33. Okay, yang the simplest number we have is 2. Tapi bila kita times 2, 1.33 times 2, we will get 2.66. Okay, bila 2.66, dia still lagi 0.6. So 0.6 kita tak boleh run off jadi 3. So we cannot multiply 1.33 with 2. So we go to the second choice. Second choice is 3. So 1.33 times 3 will become 3.99. So 0.9 we can run off jadi 4. So if we multiply hydrogen punya ratio with 3, yang lain pun perlu multiply by 3. So finally we get 3, 4 and 3. So empirical formula is C3H4O3. Okay, this part ada apa-apa mau tanya?
Tidak.
Tidak, okay. Next, we calculate for molecular formula. So we know that the relation between molecular formula dengan empirical formula. Okay, is related by N. So we need to calculate for N. So N is relative molecular mass over empirical formula. So given in the question, relative molecular mass is 176. So empirical formula yang ni, 88 we calculate from empirical formula that we have here. So 12 times 3, so kita ada 3 carbon, 1 times 4, 4 hydrogen, 16 times 3, 3 oxygen. So we get 88. Then lepaskan multiply, divide, kita ada N equals to 2. So bila this one N equals to 2, so sini N equals to 2, so empirical formula is C3H4O3. So to get the molecular formula, kamu just multiply. So carbon will become 6, hydrogen is 8, oxygen 6. So that one ialah molecular formula. Okay, next example. Second type of question. If you are given the mass of the element. So actually this one is simple. So we have 18.3 grams sample of hydrated compound. Hold on. Hello? Yeah? 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 Oh yeah, kenapa? Yang di kuantum tu, boleh call number yang lagi satu tak? Bukan, itu mak saya. Okay. So we have sample 18.3 grams, so hydrated. And element, we have calcium. So calcium. We have chlorine. So Cl. Okay, this one is water. So in this question, because this is hydrated compound, so hydrated means, pernah dengar hydrated kan?
Pernah.
Hydrated means
Solution.
yeah, hydrated mean water. So in this question, we cannot separate water as H and O. Kita tak boleh separate dia sebagai H dengan O because dia come in form of water, hydrated. So kita left it as H2O. So kita just buat as usual, mass 4.4 for calcium, chlorine 7.1, water 7.2. Okay, so step macam sama tadi, kamu calculate for mole. Okay, divide by AR. So this one for water, water means 2 hydrogen plus oxygen 16, jadilah 18. So then calculate for mole, simplest mole, dan simplest ratio, so we have 1, 2, and 4. So for hydrated compound, indicate by this dot. So kalau hydrated, kamu mesti using this dot symbol. So dot and ending with water represent hydrated compound. So kamu tak boleh tulis dia as CaCl2 H2O4. Okay, even though yang ni macam betul because we have 4 for H2O, tapi this one is not a correct way to write the hydrated compound. Okay, but in calculation for MR, we still total up this water punya MR. Okay, this one is 40. Kalau kita calculate for MR lah. So this one is 35 times 2 for chlorine. So dot means plus. Kalau maths dot means multiply kan? 18. 4 times 18. So this one for hydrated compound. Any question?
No.
Okay, proceed for example 3. So this one is the most popular question in empirical and molecular formula for combustion. Okay, we have 1 gram of sample for compound A burn in excess oxygen. So here we have excess oxygen. So we have carbon dioxide and water. Determine empirical formula of the compound. So if the question just write as compound, we assume that dia ada carbon, hydrogen and oxygen. Because some question dia akan bagi tahu determine the empirical formula of the hydrocarbon. So kalau hydrocarbons mean we just have apa? Carbon
and hydrogen.
Yeah, carbon and hydrogen only. Okay, so yang ini ada carbon, hydrogen and oxygen. So to calculate mass of carbon, okay, how do we calculate mass of carbon? Okay, carbon we have in carbon dioxide. So we calculate mass of carbon in carbon dioxide. So in carbon dioxide, how many mole of carbon?
1.
1. So mass of carbon 1 times 12, 12 gram kan? So 12 gram. So divide by total mass of carbon dioxide. Berapa total mass? 1 carbon, 2 oxygen. 1 times 12 plus 16 times 2. Jadi 44 gram of carbon dioxide times, okay, given mass of carbon dioxide 2.52 gram of CO2. So cancel this one, we get mass of carbon. Okay, same goes for hydrogen. So mass of hydrogen in H2O. Okay, kita hanya ada hydrogen dalam H2O saja. So in H2O, how many mole of hydrogen?
2.
2. So 2 gram hydrogen over total water. Total water? 2 times 16. 18 gram of water times total mass of water here 0.443. So 0.443 gram H2O. Then we will get mass of hydrogen. Okay, to calculate mass for oxygen. Okay, oxygen we have in carbon dioxide and also in H2O. How do we calculate mass of oxygen?
Minus.
Yes, minus. We have mass of sample, so 1 gram sample minus mass of hydrogen plus mass of carbon. Okay, we have proper step here. So this one untuk calculate mass of carbon. So 12 gram of carbon divided by 44. Okay, here we have mass of carbon. Okay, same goes for hydrogen. Mass of hydrogen in H2O, 2/18 times mass of H2O. So we have mass of hydrogen. Okay, then to calculate mass of oxygen, mass of sample minus total mass of carbon and hydrogen. So macam biasa kamu construct a table, calculate for simplest ratio of mole. So here we have 3.5. Okay, actually yang ni boleh we simplify as 3.5. So this one is 3. So it's 3.5. 3 and 1. So we times by 2 to get the whole number 7, 6 and 2. So ini empirical formula. Okay, so we just finish for empirical and molecular formula. We have 2 exercise for this one. Boleh sambung lagi? Atau semua dah tertidur ni?
Mungkin terlepas lagi ni.
Hah?
Fikir.
Saya okey je, kamu ni? Nanti panjang-panjang saya cakap ni, kamu okey?
Mungkin rehat sedikit.
Nak rehat sikit? Ada untuk apa tu? Concentration measurement tu. Sambung sikit ya? Boleh sambung sikit lagi?
Boleh.
Okey. Okey, molarity. Okey, tadi kita dah define ni. Mole solute over volume of solution in liter. Okay, for example. Okay, we have here 0.586 of Na2CO3 in water. So Na2CO3 is solute, solvent, solution.
Solute.
Solute.
Yeah.
Okay, so kita tahu molarity is mole of solute over volume of solution. So yang ini convert to mole. So 0.586 divide by MR. So MR untuk Na2CO3 ini kamu cari dari periodic table. So over 106. So kita dapat mole of solute. So mole of solute divide by, so this one solvent, solution, convert to liter, so it becomes 0.25 liter. So ini just straightforward question. Convert and substitute to formula. Okay, we have 2 exercise for molarity. Okay, kamu cuba. Okay, next molality. Oh, this one saya tinggal ni and okay, molality is number mole of solute over mass of solvent in kg. So mole of solute over mass of solvent in kg. So the unit mole per kg. So example 1, we have sulfuric acid. So sulfuric acid ni apa? Solvent, solution, solute.
Solute.
Solute. So we have solute sulfuric acid 24.4 gram. So we have 198. Yes, we need ialah
Solvent.
solvent. Okay, so molarity, mole of solute over mass of solvent in kg. So solute given in mass. So divide by MR dulu. So this one MR for H2SO4 from periodic table. Okay, kamu calculate dapat mole. So substitute mole in formula. Then convert mass of water to kg. So 0.198 kg. Then we have this one as a final answer. Okay, another example for molality. Okay, molality. Mole solute over mass solvent in kg. So solute given, ini ialah solute. Okay, by dissolving 0.3 mole of CuCl2 in. Jadi means yang ni yang dia dilarutkan. So this one is a solute. So given solute 0.3 mole. Okay, and mass of solvent. Tapi sekarang solvent given in mole. So to calculate mass, apa formulanya? Mass equal to mole times mR. So mole for water 40, mR for water is 18. So dapat mass 40 times 18. So 720 gram. So kita perlukan mass of solvent in kg. So 0.72 kg. Zero point 0.4 167 mole per kg. Final answer. Actually the best decimal point kamu tulislah 3 to 4 decimal point untuk final answer. Okay, 0.4167 mole per kg. Okay.
Okay.
Okay. 3 exercise for molality. Okay, we proceed for mole fraction. So ini kita dah define tadi mole for component, the component over total mole of that component present. So total mole fraction will be equal to 1. So for example, we have here ni pun sama, CuCl2 solute. So this one is solvent. So calculate mole fraction of CuCl2. So fraction CuCl2, mole CuCl2 plus mole water. So 0.3 over 0.3 plus 40. So do we have unit for mole fraction of water? For CuCl2, mole fraction tiada unit kan?
No.
Yes. No. No unit.
7.44 exponent negative 3. Okay, next example, mole fraction for each component. So each component refer to C7H8 and C6H5Br. So given, dua-dua given in mass, so convert mass to mole. So mole C7H8, mole total C7H8 plus mole C6H5Br. So calculate mole untuk each dulu. So mole for C55 divide by mole for toluene. Toluene is C7H8. So this one bromobenzene C6H5Br. So calculate mole for each component first. Then to calculate mole fraction for toluene. Mole for toluene divide by total mole. So this one mole toluene plus mole bromobenzene. Okay, to calculate for mole fraction for bromobenzene, okay, we can use this shortcut. 1 minus 0.63. Okay, percentage by mass, mass of the solute over mass of solution in percentage means times 100. Okay, what is the percentage by mass in the solution? So we have formula percentage by mass equal to mass of solute over mass of solution times 100. So solute, okay, this one is solute, 0.892 divided by solution. So solution is
0.
Mixing of solute and solvent kan? 54.3. Yeah. 892, 55.192 times 100.
Mm.
1.6. 1. Yeah. 1.6 betul?
1. Yeah,
1.6%.
1.61. 4. Yeah.
Okay. Okay, calculate another example. 16.2%. So formula percent W over W equal to mass solute over mass solution times 100. So given in percentage 16.2%, so 16.2 over 100 mass solute. So urea is solute, 5, solution. So solution is water. So we need to water is solvent. Sorry. So this one solvent. So we know that solution is solute plus solvent. Okay, so we can calculate for solvent. Mass solvent ataupun dia ialah actually is of water. Anyone dapat? Semua pergi mana? Tertidur ke sudah ni?
Kat meja.
Is it 20?
25.86.
25.86, yeah.
25.86.
Sorry.
Yeah.
Yeah. 25.
Oh, sorry, 25.
Yeah.
Dah.
Hmm.
25.86. Okay, last one. Okay, ni exercise. And last one, percentage by volume. Okay, same as percentage by mass, but this one is in volume, solute over solution times 100. Okay, what is the percentage? Percent V over V equal to volume of solute over volume of solution times 100. So solute is alcohol, 25 ml. Solution is mixing of alcohol and solvent. So 200.
14%.
Yes, 14. Okay, we have exercise for volume and also another exercise. So how many total of exercise that we need to do? Okay.
So many.
Taklah. Not so many. We have weekend kan? Weekend no work to do. Okay. We start with this one. Oh yeah. Exercise 1 and exercise 2 for empirical and molecular formula. So 2 here. And molarity 2. Molality 3. Mole fraction. No exercise. Mole fraction. Percent by mass. 2. Percent by volume 2. And final exercise 3. Overall is 14. Yes, 14. Just 14 exercise. Actually, yang ni semua simple exercise. Okay, to remind you how to use the formula. Okay, if you have any question, okay, just WhatsApp. Okay. Okay, yeah. Until now, do you have any question before we end up this lesson?
No question.
Okay, so kalau ada apa-apa problem boleh WhatsApp ya.
Okay.
Okay, so thank you for today. Okay, actually we will discuss all the 14 exercise in class next week. Okay, just be prepared with your answer.
Okay, madam.
Okay, madam.
Okay, thank you. Okay, bye.
Thank
Thank you.
Thank you.
Thank you, madam.
Thank you, madam.
Yeah, bye.
Thank you, madam.
Thank you, madam.
Okay, thank you. Bye.